Start the recording. I record all these sessions, and the way this thing works is that I have a drawing tablet here, and if you have two equations and two unknowns, use the substitution method. X plus 5, I substitute 5 for y and solve for x. Do you have some specific problems you can verbalize and we can solve?
Yeah. There's one that's 2x plus y equals -15. And then the other equation is y equals 5x plus 6.
Okay. Whenever you have two equations and two unknowns, as you know by now, there's two choices. You can solve it by substitution or you can solve it by elimination. When one of the variables is fully defined, like y is, substitution almost always works better. So all we're going to do is take whatever y is equal to and substitute it into the first equation.
Okay.
So 2x plus 5x plus 6, that's y, equals -15. Now we have one equation and one unknown. We can always solve that. Let's solve this equation. What do you do next here?
Are you asking me?
Huh? Yeah. My tutoring sessions are not about me lecturing to you. You get enough of that in school. It's all about me asking you how to do the problems. In other words, that's what it is I lay out a problem and I ask you to give me the next line. If you don't know how to do it, I can give you a hint or help you. But the way to learn this stuff is for you to do it, not to just listen to me telling you how to do it.
Okay, well, do you do 2x times 5x?
No, we're going to add it. Let's first of all remove these parentheses. Now I can go ahead and remove them. They're not really doing anything at the moment because everything was being added. I didn't need them. So now you can combine like terms. So
it would be 7x plus 6 equals -15?
Correct. And what's the next line? What's the next step? What am I going to do next?
Here, subtract 6 from both sides.
Okay. So what's that equal to? It's -15 minus 6.
-21.
And the last step?
Divide by 7 on each side.
There you go.
Okay.
Okay. So substitution is actually the easier of the two methods. It's just it's not the best method. If I turn this second equation into, in other words, if I put both the x and the y on the same side, so I make it look like this. Now I've got both equations are in standard format. Well, when both equations are in standard format, the best way to solve it is by elimination. And we're always allowed to add or subtract any two equations. So I'm going to subtract these two because when I subtract them, y will go away.
Okay.
And that's the whole point, is I'm trying to eliminate one of the variables. Well, if I subtract it, I got 2x minus a minus 5x, that's 7x. And if I take -15 minus 6, I get -21. There's my solution that I came up with doing it the other way.
Okay, so
it all depends on the format that the equations are in as to which method you want to use.
Okay, so like my homework says solve the following systems using the substitution method, and then it has two like standard form equations or whatever.
Okay.
So how would you do that?
Well, give me both of them.
3x minus 2y equals 2, and 8x plus y equals 37.
If they force us to solve this by substitution, then I need to turn one of these equations and define it in terms of one variable. Well, which one's the easiest one to do that with?
Y.
Second. Let's call this equation 1, equation 2. In other words, I can turn the second equation into y equals by just subtracting 8x from both sides.
Okay.
So y equals 37 minus 8x, right?
Okay.
Now I have one equation completely defined in terms of one variable, and that's still equation 2.
Okay.
So take whatever y is equal to and substitute it for that y right there.
Okay.
So now what do you get? 3x minus what?
Minus 2, and then in parentheses, 37 minus 8x equals
2. Now we got one equation, one unknown. We can solve it. First step in solving this.
Well, I don't really know how to do it when there's a 2 in front of the parentheses. Do you multiply it?
Yeah. In other words, our goal is to get rid of those parentheses. We can't gather like terms until we lose the parentheses. Okay. Well, this means minus 2 times each of these, so we're going to distribute it.
Okay.
So minus 74, that's minus 2 times 37,
okay,
plus 16x, which is minus 2 times minus 8x.
Okay.
Becomes positive.
Yeah.
Okay. Now I got easy. I don't have any parentheses anymore. Let's gather all the terms with x in them, put them together on the left side, all the numbers on the right side. What do you have?
19x minus 74 equals 2.
Which means 19x equals 76.
Okay.
Doing both steps at once, which means x equals 4.
4.
76 divided by 19.
Okay.
Okay?
Okay.
What's another one? Give me another one. Let's see if you can do this one entirely on your own.
X minus 4y equals 12. And negative 3x plus 5y equals negative 15.
Negative what?
Negative 3x plus 5y equals negative 15.
Which equation are you going to be able to solve for one variable the easiest?
The first one?
Uh-huh.
Okay.
So give me the first equation solved in terms of one variable.
Would it be negative 4y equals...
No. In other words, you picked the first one because it had just an x. Because all we have to do is add 4y to both sides.
Oh, okay. Okay, so... x equals 12 plus 4y, or minus 12? No, plus 4y.
Yeah. In other words, all I'm doing is rearranging equation number 1 so that I get it in terms of one variable.
Okay.
That's the key to use substitution. It doesn't matter whether it's x or y.
Okay.
The key is just to get one variable in terms of the other.
Okay.
Now, let's substitute. And we need to substitute in equation 2.
Okay.
Yeah, we do. If we substitute in equation 1, we'll end up getting 0 equals 0, and we won't be able to solve for anything. So you always go to the other equation to do your substitution.
Okay. So would it be -3 and then in parentheses 12 plus, no, wait,
Yep.
is it? Yeah?
Sure. In other words, we're substituting for x, and we know x
Okay.
is equal to that.
Okay, and then plus 5y equals -15.
Okay. Notice we now have one equation, one variable. Let's solve it. And this time, let's solve the whole problem because up until now, we've only been solving for one variable. And they always want both variables. So this allows us to solve for y. Then we'll go back to one of the original equations and solve for x once we get an answer for y. So what's the next step here?
So distribute with the parentheses?
Yep, let's get rid of the parentheses, which means distributing that -3. So what's the next line? What should I write?
-36 minus 12y plus 5y equals -15.
Next line?
-7y minus 36 equals -15.
Next line?
-7y equals 21.
Next line.
And then y equals -3.
Okay, so we solved for one variable. Now we still have to solve for x. Well, that's pretty easy. We can go back into any equation and solve for x. I could use this equation, but the easy one is this one here. Because we just solved for y. Y is -3. So if I substitute -3 for here, what is x?
24.
No, it's 0. In other words, it's 12 plus a -12.
Oh, okay. So it would be x equals 12 plus 4, and then in parentheses.
Exactly. Whatever our answer was for y. Yeah, whatever our answer was for y, we're going to plug it in and solve for x. So that would be 0.
Okay,
so our two answers are x equals 0, y equal -3. That's what you want to give as answers. And let's just make sure those answers work. When x is 0 and y is -3, is this first equation true?
Yes.
Okay. The second equation, when x is 0 and y is -3, is that true?
Yes.
Both of those answers are good then.
Yeah.
And that's essentially how you're going to do all of these problems. You're going to solve for one variable, and then solve for the second variable, and then verify that those solutions work in both equations.
Okay. And then another one I've been having problems with is like when it gives you two equations and then you find the vertex and then determine whether or not the quadrilateral could be a rectangle.
Okay.
So the first problem is 4y plus 2x equals 20, and x equals 8 minus y.
Okay. So the question again is to clearly when you have two equations and two unknowns, which is what we have here, you generally have one unique solution for x and y. Okay. I'm not sure, I didn't hear the first part of the problem. Would you reread the first part?
It says find the coordinates of the vertex and determine whether the quadrilateral could be a rectangle.
Okay. So let's graph this. If I graph the first one, when it's in standard format, a really easy way to graph it, it's a straight line. In other words, both of these are straight lines. An easy way to graph it is by graphing the x-intercept and the y-intercept. You don't even have to worry about slope.
Okay.
To graph the x-intercept, that's where y equals 0. So I plug in y equals 0, x is going to be 10.
Okay.
To graph the y-intercept, that's where x is 0, right? When you're on the y-axis, x is always 0. So I plug in 0 for x, solve for y, y is 5.
Oh, okay.
So there is the graph of the first line, first equation, equation number 1. The graph of the second one, well, the easiest way to graph that is to turn it into an equation of y. Let's put it in y equal mx plus b format. So if I move the y over and the x over, I get y equal minus x plus 8. Same equation, right?
Okay. Yeah.
I can graph this because I know it goes through y-intercept of 8, and it has a slope of negative 1.
Okay.
So the vertex they're talking about is probably there.
Okay.
And I'm not quite sure what the rest of their question means. They said something about a parallelogram and a rectangle.
It says determine whether the quadrilateral could be a rectangle.
Okay. The quadrilateral they're talking about has to be this, I presume, since it's the only quadrilateral made.
Okay.
When I graph these two lines, there's only one quadrilateral. There's a triangle here, and there's a triangle there, but that's the only quadrilateral.
Okay.
Okay? For that to be a rectangle, what would be necessary?
The opposite sides have to be equal.
Well, I'd have to have 4 90-degree angles. In addition to that. Okay? But from my graph, I can't really tell whether my sides are equal here. I can't tell if this side is equal to that side or that side. But I can certainly see that I don't have right angles. That's not a right angle here. And most importantly, I know that this is not a right angle. Why do I know that's not a right angle? Because if those two lines were perpendicular, then the slope of one would be the negative reciprocal of the other. Remember that parallel lines have the same slope. Perpendicular lines have negative reciprocal slope.
Yeah.
Well, the slope of this line was minus 1. This line here. The slope of the other line is 1/2. Minus 1/2. This slope is minus 1/2. I got to go down 5 and over 10. So that's minus 1/2. This slope is minus 1. Well, those are not the negative reciprocals of one another. Therefore, that is not a right angle. And if it's not a right angle, it's not a rectangle.
Okay.
That's all you really need to prove, is that one of these angles is not a right angle. I also know that's not a right angle because I got a slope. That would have to be a horizontal line for that to be a right angle. And a horizontal line would have a slope of 0.
Okay. Okay. Do you want to do one more?
Sure. Yeah, we got 4 or 5 minutes here. Let's do one more.
Okay, so this one is 2x plus y equals negative 4. And 2x minus 3y equals negative 15.
And are we just supposed to solve this, or is this another?
This is the vertex and quadrilateral one.
Okay.
Or rectangle thing.
So before we graph it, let's figure out what the slopes are and see if we have a negative reciprocal slope. We might be able to prove it's not a rectangle immediately. So let me give some, solve the first equation for y.
Would it be y equals negative 2x minus 4?
So our slope there is minus 2. Solve the second one for y.
What do you do with, like, the 3? Because I don't...
I'm going to divide both sides by minus 3.
Okay.
That'll leave just y on there. So now I have this.
Okay.
Okay, and that simplifies to y equal 2/3 x plus 5. Slope is 2/3.
Okay.
No perpendicular. If the slope was 1/2, then this line would be perpendicular to that line.
Okay.
The moment I discover that the slope is not the negative reciprocal, I know they're not perpendicular, and if they're not perpendicular, it's not a rectangle.
Okay.
And also, the slopes weren't 0 either. One of the slopes would need to be 0.
Okay.
At least if you were making a quadrilateral with the x and y axis. In other words, the previous problem, the only quadrilateral that was made was with the y and the x axis. In other words, I had that line, and then I had the y axis and the x axis. So the only chance of making a quadrilateral is with using the two axes also.
Okay.
For that quadrilateral to be a rectangle, I need a horizontal slope and a vertical slope. So I need slopes like y equals 2 and x equals 5. That makes a rectangle.
Okay.
Because x equal 5 would be a vertical line, y equal 2 would be a horizontal line, and this thing here would be a rectangle.
Okay.
But I suppose if you had enough lines, you could make a rectangle without a horizontal line. In other words, if you gave me these lines, there's 4 lines that do make a rectangle.
Okay.
And none of them are horizontal and none of them are vertical. But the key is that these are all right angles because the slopes of these 2 lines are the negative reciprocal of the slopes of the other 2 lines.
Okay.
And once you have 4 right angles, you have a rectangle. And you don't need equal side. Well, by definition, this side's equal to that side, and this side's equal to this side, but all 4 sides aren't equal to one another. Doesn't have to be a square.
Okay.
All right. Ariana, it's Ari, right?
Ari.
Ari, I'm sorry.
It's okay.
I'll try to remember that. We have another appointment scheduled, I think, next week sometime. Yeah. So I hope this has been helpful. I'll call the same number next week, and we can figure out whether you need to do it on your brother's computer or your computer.
Okay, sounds good.
If you like. All right? I will talk to you next week.
Okay, thank you.
Bye-bye.